Hello students, today we are going to understand a topic from the chapter fluid mechanics. This is actually a question that came in NEET 2025 and I think most of the students find it very difficult to understand. So today we will try to understand the concept behind this question. So basically what they are saying in this question, I will actually redraw it for you guys so that you can understand it better. So they are saying there is a water tank, okay? There is a tank which have its two walls separated by a distance of L in the x direction. Basically this is the x direction and the distance is L, and the another side of the wall is actually in the z direction, which is very much wide, that is given in the question. And we can take the height of the tank as in the y direction, right? And there is a liquid which have a surface tension of S is actually is filled in this tank, okay? And the liquid surface is actually, as we move towards the x direction, is has the liquid surface has risen up to an extent and making a meniscus type of surface, curvature that is making. So in this question, actually it's asking the height that the liquid surface has risen up to, right? The topmost point the liquid surface has reached to the and the distance between the bottom part of the tank, right? So this is the distance, and I'm going to take this as y. So see, you have to see that um, as this is an open tank, so I can say that the actually the atmospheric pressure is acting on it. So can you tell me, as the height from this beginning from this topmost point to the lowest point of the tank, what is the pressure difference due to the atmospheric pressure? What is the pressure difference that is being applied on the water? That is, we can say that is rho g, and the distance is y, right? And also, as the water level is actually making a curvature due to its surface tension, we know that there will be a excess pressure that is being developed inside the water surface, right? And what is that? That is actually will be surface tension divided by radius of curvature, right? But here actually the radius, the problem is that the radius is not same for every point. It's actually the radius is changing with the value of y, right? So you have to solve the radius, and you have to determine the value of radius with the quadratic equation. But from the perspective of NEET, you don't have that much time. So I will try to I'm telling you to remember that whenever something like this comes in a question, what do you have to do is just simply take this as r is equal to dx square by d2y, right? This is the value. Now if I put this value here, this value will become s into d2y by dx2, right? Now as you can see that actually the liquid is in static position, right? It's neither going upwards or it's not compressing, nothing. So we can say that both of these pressure is actually cancelling each other out. So we can actually equate them, and what will be that s into d2y by dx2 will be equals to rho g y, right? Now if I just simply put the s on the right hand side, it will become d2y by dx2 rho g by s into y. And I think the second option will be the right one. Hope you guys understand that. Thank you.